Hi everyone, I hope you're enjoying your day. Today we are going to be continuing in our geometry lessons. We're in chapter 3 and now we're moving on to the second section. So yesterday we talked a lot about vocabulary and how a transversal can cut two lines and then form certain angle pairs. Well, today we're going to add an additional element to that, where now our lines are going to be parallel, and that is really going to cause a lot of special and unique relationships between angles. So today I'd like for you to be able to identify angle pairs made by parallel lines and transversals, and then be able to solve problems by applying their relationships. So, we have a postulate and a couple theorems that we need to talk about first, and we're going to use this image right here to kind of help us. What I want to remind you is this guy right here is the transversal, and here we have R and S are parallel to each other. Now, if you don't remember what the parallel symbol is, let me try to find something. Here we go. This color will work. If you see a little arrow kind of like that drawn on your lines, then that means that they are parallel to one another. So here we're going to have a couple postulates and theorems talking about how certain angles are going to relate to each other. So this one is the same side interior angles postulate. So that might be say this angle and this angle. These are same side interior angles. That would be an example of this guy up here. So same side interior angles is this. If a transversal intersects two parallel lines, then their same side interior angles are supplementary. Supplementary. There we go. So that means, remember, supplementary means adding up to 180 degrees. So I'm just going to put 180 degrees in parentheses behind to remind you. So this angle plus this angle are going to add to 180 degrees. They are on the inside and they're both on the left of the transversal. That also means that this angle over here and this angle over there are also going to add up to 180 degrees. Next, we have alternate interior angles. So an example of that in our image would be, say, this guy and that guy. They are alternate interior. Alternate interior angles work like this. If a transversal intersects two parallel lines, then their alternate interior angles are congruent. So that means this angle right here drawn or kind of marked in pencil and this angle right here marked in pencil have the same measure. Next, we're moving on to alternate exterior angles. So I'll do that in dark blue. Here's an example of alternate exterior angles. Notice how this one down here is on the left, this one up here is on the right of the transversal, and they're both on the outer edges of the image. So alternate exterior angle says this, and they always start with if a transversal intersects two parallel lines. We have to have a transversal and we have to have parallel lines before this is going to happen. So there's always that kind of conditional in there. So notice it's if then, if then. So it says if a transversal intersects two parallel lines, then their alternate exterior angles are congruent as well. So that means this line down here marked in dark blue, angle, and this angle up here marked in dark blue are congruent or have the same measure. That would also mean that this guy up here and this one down here would have the same measure as each other as well. For our very last theorem, it is the corresponding angles theorem. And notice all of these lined up with some type of angle pair that we talked about yesterday. So we've already talked about corresponding angles. We've talked about alternate exterior angles and so on and so forth. So these should hopefully be starting to get ingrained in you a little bit. So anyways, corresponding angles theorem. Once again, we need a transversal. So if a transversal intersects, and we need two parallel lines, then their corresponding angles are congruent. So let me get one more color. I'll use the highlighter so you can see it. An example of corresponding angles in this image up here would be, just one example, would be this guy and this guy. So notice how they are both on the right side of the transversal and they are both below the other line that forms them. So they would be the same measure or congruent to each other. So now we're going to use these properties and apply it to solve some algebraic problems. In this first example, it says find each angle measure. And we want to find the measure of angle ECF. So ECF is ECF right here. It is this guy. Now, there are a lot of ways that you can do this. You might say, oh, this angle plus this angle is going to equal 180 degrees. Or you might try to correspond it with something different. The easiest way is going to use corresponding angles, and you are going to say, oh, hey, this angle and this angle are corresponding. Notice they are both below the transversal, and this one is to the right of this line, and this angle is to the right of that line. We also have our little, I ought to point that out. Notice how this is marked parallel. So we have that information as well. So because these are in corresponding spots, we know that this guy is 70 degrees as well because they have to be congruent or the same measure. Next, we have the measure of angle DCE. So DCE is right here. I will mark it, and I'll do it in yellow. Now this one, there really is an easy way and a hard way to do this. You could say, oh, hey, this angle and this angle are corresponding, so I'm going to set them equal to each other, solve for x, and then plug x back in. You can absolutely do that. Yes, you can. I'm going to do it an easier way, though, because remember how we said, oh, hey, this angle right here is 70 degrees. Well, now I know 5x plus 70 is going to get me 180 because this is a linear pair and that forms a straight line. So I have 5x plus 70 is equal to 180, and now I'm just going to solve for x. So minus 70, actually no, I'm going to stop right there. I'm not going to solve for x because I don't need to. I can just replace this with the whole angle, because whatever this angle equals, it has to add up to 180. So minus 70 from both sides, I'm going to say measure of angle DCE is equal to 110 degrees. There, I'm making it even easier. So what I did with there, I said, okay, this angle has to be 70. Sure, there's a 5x in here, but the total has to add up to 180 with the 70, so I know the total is going to be 110. Now, if it asked us to solve for x, then we would need to do the equation that I was just about to solve, but it didn't ask us for that, so we're not going to do it. Work smarter, not harder, right? Okay. Our next problem, it says, find the value of x and each indicated angle measure. So this time, we are going to have to solve for x. So our first problem is find the value of x. Well, we have x in a couple different places. And once again, we have a couple options for doing this. So you might decide, like say that you had a problem like this on a quiz, there would be multiple ways that I would accept for you to get to your answer. For example, you might say, this is just one way, you might say, hey, this angle and this angle are vertical angles. And I know that vertical angles are congruent to each other. So I can say 75 is equal to 2x minus 135. That is one way you might do this. You might also say, hey, this angle right here and this angle right here are congruent to each other. So I could say 2x minus 135 is equal to x minus 30. That works as well. You might also consider this guy right here. And this would take a couple steps, but you might say, right here is x, and this angle right beside it must be 75 degrees. How would we know that? Because these are in corresponding spots. And then you might be like, okay, well, these two things have to add to 180 because it forms a straight line, so I'm going to get my number that way. I can continue on. There are other ways to solve this as well. I will not, exhaust those options for you, though. What I'm getting at is you can do this more than one way, and as long as you show your work, it is okay, and I will accept your reasoning. I'm going to do the method of vertical angles just so you can see that. I'm going to say, all right, these two angles are congruent to each other because they are vertical. So I am going to say that 75 is equal to 2x minus 135. And now I'm going to start solving. So I'm going to add 135 to both sides. That's going to get me 210 is equal to 2x. Divide by 2 on both sides, and I get x is equal to 105 degrees. Whichever way you solve this, like if you decided to do the supplementary angles right here or complementary angles right here, either way you solve this, you should still get x is equal to 105. You're not going to get a different value for a different way you solve it, unless you do incorrect math, of course. Next, it wants us to find the measure of angle EDG. So EDG is this guy right here. So all I'm going to do is take this 105 and substitute it in for x. So I have 105 minus 30, and that's going to equal 75 degrees. And finally, I want to find the measure of angle BDG. And where is that? It's right here, BDG. So that's this guy. I'll highlight him in yellow so you can see him. That one right there. And you might be noticing, well, hey, BDG just equals x. And we already solved for x in problem A. So I know that this must equal 105 degrees. So BDG equals x, and x equals 105 degrees. Therefore, measure of angle BDG is equal to 105 degrees. That is, we just use the transitive property. If measure of angle BDG is x and x equals 105, then measure of angle BDG must be 105. Transitive property right there in action for you. Here we have a little bit more of a complex problem now. We're getting a little bit more advanced on you. So it says, find the values of x and y in the diagram. Let's break down what we have going on in this diagram first. We need to locate which lines are and which lines are not parallel. So here are our arrows. So L, M, and N are all parallel to each other, but P and Q are not parallel. So we want to keep that in mind. We're just solving for x, so I'm going to solve for x first. And I'm going to locate where I have x alone. Notice how I have an x and a y in this expression. So I don't want to start with that because I have two unknowns and I can't replace it with anything. So I'm going to start down here because it's only one variable in the expression. So I'm going to start with this angle. And I'm going to try to find another angle that I'm able to relate it to. I am not allowed to relate it to this guy up here. I repeat, you are not allowed to do that. The reason being is P and Q are not parallel. I can only correspond to angles if the lines are parallel to each other, which means if I cover all of this stuff up right here, now I have my 3 parallel lines and my 1 transversal. I can compare this 5x with this 60 right here. Notice how they're both on the bottom of the transversal, and the 60 is on the left of this line, and this 5x is on the left of that line. So I can now set up my equation 5x is equal to 60. And I'm going to label them corresponding angles are congruent. I'm just going to list why you're doing this. So now I'm going to divide by 5 on both sides, and I get x is equal to 12. Beautiful. Okay, now I'm ready to solve for y. The only expression with a y in it is right here. Let me mark that angle with 2 lines. And I'm going to ignore this transversal down there because it is not helpful to me anymore. So I'm only looking at this transversal and my 3 parallel lines, and somehow I need to relate 5x plus 4y to this 55 right here. Well, that 55 is an alternate interior angle to this. And alternate interior angles are congruent to each other. So I'm going to label that for you as well. Alternate interior angles are congruent. So that means 55 is equal to 5x plus 4y. I know what x is equal to. X is equal to 12, so I'm going to substitute that in. And I'm going to multiply it, so 55 is equal to 60 plus 4y. Now I'm subtracting 60 from both sides. I get negative 5 is equal to 4y. Divide by 4. Don't let the negative or the fractions scare you. It's okay to have negative fractions for your answers. They're numbers too, so y is equal to negative 5 over 4. And that's my final answer. We have one more example to go through and then we're done. It says find the values of x and y and all the angles of the trapezoid. So really, once we calculate what x equals and what y equals, we've done the hard part and we just substitute everything back in. Let's kind of highlight what it tells us again. So here we have our arrows, meaning that these 2 lines are parallel to each other. Now, they are cut by 2 different transversals, but let's just focus on one at a time. Let's look at these 2 angles. And it is cut by this transversal. 2x and x minus 12, those angles, they are both on the right side of the transversal, and they are inside. Because they are same side interior angles, they are supplementary. So let's show that one more time. Up here, same side interior angles are supplementary, or they add to 180 degrees. So I am going to say down here in this example that 2x plus x minus 12 is equal to 180. I'm going to start combining like terms and solving for x. So I have 3x minus 12 is equal to 180. Add 12 to both sides. 3x is equal to 192. Divide by 3, and I get x is equal to 64. Wonderful. We're going to do the same thing with the y's now. So with the y values, I have 3y and y minus 20. These are same side interior angles as well. They are both on the left of the transversal, and they are both on the inside of the parallel lines. They are in between the parallel lines. So I'm going to have 3y plus y minus 20 is equal to 180, which gets me 4y minus, oh, that's a plus sign, I'm sorry. I was looking at that. This should say plus. It's kind of, the printer wasn't very dark, so it looks like a minus. So that should say plus, my apologies. Plus 20 is equal to 180. Now I'm subtracting 20 from both sides. I get 4y is equal to 160. Divide by 4 on both sides, and y is going to equal 40 degrees. So that was the first part, find the values of x and y. We also want to find all the angles in the trapezoid. So all we have to do now is to just take our values and substitute them in for each one. So what is 2 times 64? You can put it straight into your calculator, I don't mind. And I'm just going to do mine like this. I'm going to say this top one is 128 degrees, and I'm putting it right here beside it. Then I have 3y, so that means 3 times y, or 3 times 40, which is going to be 120 degrees. Here I have y plus 20, which is going to be 40 plus 20, or 60 degrees. And right here I have x minus 12, which is 64 minus 12, or 52 degrees. Those are all the problems that we're going to do today. We will be practicing with these just to get you more used to all the patterns that we have. But until then, see you later.